Now at this point in the game, we have two options. We can either start using the shelf tools, or we can start making everything from scratch. Now depending on who you talk to, when it comes to learning this stuff, some people say it's a bad idea to rely on the shelf. Others say, the shelf isn't really the problem. I'm of the belief that the shelf is convenient. I use it all the time just for convenience sake. And I'm going to show you what these nodes do anyway. So that being said, let's use this wispy smoke setting, and that'll get a lot of things set up for us ahead of time. Be sure that the steam source is selected. That again is all of this geometry right there. And then go up to wispy smoke. What that will do is it will create a DOP network. This is where all of our pyro stuff is right now, and I'll go back to that here in a second. We also have this pyro imports, so this is where all those fields are being imported in from the DOP simulation. And then if we go to our steam source in here, you'll notice that a couple of nodes have also been thrown down. To re-emphasize the entire process, and just so that you see again what's happening, with this steam source, we have these points that are eventually going to be rasterized into fields that the pyro solver understands. If we could see that by middle mousing, and you see that by default we have two fields, density and temperature. This out density eventually goes into the DOP network, and here is this volume source, or source volumes, you'll sometimes see it be called that, will bring in everything with this path right here. Now we're preparing everything for the pyro solver, like so. That gets sent over to the smoke object, and then the smoke object goes into the pyro solver. This goes to the output, and that result is collected from the pyro imports. If we middle mouse this, now we have all of these fields that the solver gave us, and this is what we can use to render. So again, just a bird's eye view of the entire process. Let's go to our source and now focus on these initial particles. This pyro source node is pretty cool because this is what's going to assign the attributes to these points. So what we start with is a question of how do you want to generate these points? We can either scatter along the surface, which is very similar to just creating a scatter node like this and plugging it in. We can do that. We could say keep the inputs as well. So if we say keep inputs, it'll just keep all the same positions. Or you can also go here to volume scatter, and this will create a grid of evenly spaced points like so. I kind of like doing this grid personally. I think that it creates a very even distribution. It's very predictable. One of the issues that you'll sometimes run into is that if, let's say, you use the surface scatter and you have something that's deforming a lot, it'll create this poppy, jittery kind of effect. And sometimes that will show up in your source and it'll just kind of make everything look weird. So again, I like using this volume scatter. Now, if you had some fire that was being projected outwards, let's say like a flamethrower, then you would actually want to run a particle simulation before this pyro source and then choose the keep inputs. So if you had a pyrosim that was flying stuff, it would just keep those particles. Anyway, that's some of the ideas behind this particular thing. We have this initialize set to source smoke, which is going to assign two fields to these points eventually, density and temperature. Smoke needs density and temperature to work, and I'll talk about that again once we get to the DOPs. Now that we have this, let's set our default value to 1 so that we are existing with values that are between 0 and 1. Well, actually right now, if we go to our geo spreadsheet and we go to temperature and density, everything is 1. And I don't really like that because I think it's a good idea to break up these values and add some variety. So let's use the attribute noise node and set this after the pyro source. This is exactly what it sounds like. It's just going to add a bunch of, it's going to add noise to the values here. instead of saying CD, let's set our attributes to density and temperature. And now, if we go to our Geo spreadsheet, you can see that we're starting to break up these values. So I found this video online, and this is a thermal video of how hot it is at the surface of a cup of coffee. And as you can see, the temperature is not actually distributed evenly across the whole thing. We still just have a general amount of heat always being consistent. But at the same time, it's breaking up, it's changing its shape over time, and we want to actually mimic this behavior because that's going to get us closer towards a realistic sim. To do this, let's go ahead and take our noise. I'm going to set a minimum value. That will give us the overall heat, and then let's try to get as close as we can to mimicking the general effect of that noise kind of moving around.